So we shall describe two very commonly used techniques by which you can balance the maximum attained log likelihood and the number of free parameters that you are estimating. The first one that was proposed is called AIC's information criterion and commonly abbreviated to AIC, though originally when AIC proposed it, he did not call it AIC information criterion, he called it an information criterion, but deliberately chose the acronym AIC, possibly hoping that his name will be eventually be placed in place of A. And the formula for that is this: AIC is minus twice log likelihood ratio. So it is minus twice log likelihood ratio evaluated at theta hat. Theta hat is your MLE plus twice P. P is the number of free parameters. So you can see if your maximum log likelihood goes up, AIC falls down, and if the total number of free parameters goes up, in that case AIC will go up. So AIC is kind of a negative way of measuring goodness of fit. So if a model is better, AIC will be less, which is kind of weird. You call it information criterion. So if it grows up, you'll say that the information is more, but that's how traditionally it is defined. In fact, it is one way of roughly estimating what is called the Kullback-Leibler divergence, something that we need not worry our head about in this class, a way of measuring distance between the empirical distribution of the data and the estimated true underlying distribution. So the original paper by AIC did that, but a better way to remember this formula is as a trade-off between the maximum log likelihood that you can attain and the number of free parameters that you have to estimate in order to attain it. Now, revolving around the same idea of this trade-off comes the next one. In fact, there is actually many such information criteria, all revolving around the same idea, but the most popular of them is BIC, called Bayesian Information Criterion, sometimes called SBC, Schwarz's Bayesian Criterion, because it was proposed by a Bayesian by the name of Schwarz. Nothing to do with the Cauchy-Schwarz inequality. That's a different Schwarz. This Schwarz is a lady and without a T in her name. So it is sometimes called SBC, Schwarz Bayesian Criterion, mostly called BIC, Bayesian Information Criterion. Essentially the same formula. We have minus twice log likelihood evaluated at the MLE. So this is the maximum possible log likelihood, but plus P times log n. So the 2 is missing and we have a log n. So it kind of checks the weight of P, the number of free parameters, in light of the total sample size. So if you have lots of sample size, then the weight for P is more. And so there is some amount of justification using some Bayesian statistics that I really do not know about. So you can just try to read the original paper. But many people I have seen, they favor BIC over AIC. There is no unanimity as to which one is the best one. Most people I see favor BIC. Some people would say, for example, our textbook says that AIC is better when you are fitting the model for the purpose of prediction. Now, all these things are vague things. So how do you decide which one is good or bad? After all, BIC and AIC are themselves used to decide which model is better, and then you have to go into some further argument as to which of these things are better. This can take you to any distance, some kind of a wild goose chase, so I'm not going to go into those things. So BIC and AIC are both popular. Most of them are sort of comparable, but remember, AIC value or BIC value by themselves do not mean anything. So you cannot just take some particular model, look at its AIC and say, hey, AIC is high enough or AIC is low enough. They do not mean anything absolutely. Only when you have two models, two competing models based on the same data, you have computed the AIC values or the BIC values. you will say that the one with smaller AIC or one with smaller BIC is the better model. So this is only for relative comparison, no absolute interpretation. You cannot associate any cutoff. And the reason is simple. As I told you, this is not a situation where you are doing a test of hypothesis, so you do not have any assumed underlying model under which you can find the cutoffs. You are not even sure which model is good. So you are merely comparing them in an exploratory way.